Welcome back to Null0 Labs. In today's episode, we are still going to continue our journey with firewalls. This time, we are going to switch our attention to FortiGate, and we are going to replace our lab environment with two FortiGate firewalls. And we are going to configure them starting off with a HA active passive pair. We will set up the basics of a outbound NAT and an inbound NAT so that we can demonstrate failover and traffic flow. And so let's get into that, and we'll show you how FortiGate does it. Now here we are in our lab for today. We can see that I've replaced our Palo Altos with two FortiGates. You can see that FortiGate, we are going to use port 7 and 6 for our HA interfaces, and we're going to use port 8 for our management interface for managing the firewalls through a web browser. Port 1 will be our outside interface towards our ISP's redundant internet supply, and port 2, for simplicity, we won't use a link aggregate or port channel down to our Nexus, but just know that we can do the same setup as we could with the Palo Alto, where we can configure a ether channel, port channel, whichever brand you like to call it, and we can redundantly connect to either of the switches in our Nexus VPC setup down here. But for simplicity, we will just have the two firewalls and an interface on either side. As it doesn't have a dedicated management interface, we will go into the command line and we will quickly configure port 8 to act as our management interface. We'll give them some IP addresses so that we can reach them in the browser. And likewise, we will just be using a single address for each of the interfaces, because again, it's going to be an active passive solution. So the IP addresses will live on the active firewall and move over to the passive firewall in the event of a failover, i.e. the firewall completely goes offline, or the interface goes down on the firewall. Again, based on the fact that we are using a virtual environment here, we cannot make the failover happen by shutting down port 1. It will stay up electrically, so we will demonstrate the failover by completely switching off the left firewall, allowing the failover to happen, and we will turn it back on and fail back by turning off the other firewall. So let's first start by jumping onto the firewalls. So if we jump onto FortiGate 1 or FortiGate 3 and FortiGate 4, was it admin and no password? Let's admin and no password. So we will set it to admin. It's done. Now we're going to system interface. That's what we want. Config system interface. We're going to edit port 8. And we are going to set the mode as static. I'm going to set IP address of this one, of this management interface, to be 192.168.243/24. I'm not going to put a gateway. I'm going to set allow access. I'm going to allow HTTP, HTTPS, SSH, and ping. And I'm going to end that. That will get us going on that one. We'll do the same on FW4. So again, it's admin, no password. We will be forced to configure a new password, and we will configure the system interface, and we will edit port 8 and set the mode as static. If we wanted it to get by DHCP, we would set the mode as DHCP. Set IP as 192.168.68.244/24. And we will set allow access HTTP. I'm allowing HTTP and HTTPS. In the real world, you would just use HTTPS. You don't want to allow insecure protocols, but as we're not putting a certificate on this firewall, as it's non-production, I will use HTTP for demonstration purposes, SSH and ping. And we will end that. So that is all we have to do on our command line to get us access into these two firewalls. So we will now 192.168.243 admin later, we do not show. So that's our left firewall, this one here. And now let's bring up 192.168.68.244. This is our right firewall. Later, do not show again. So these are our two firewalls. Obviously, depending on which firmware version you are running, the interface may look slightly different, but the process is going to be the same. So we're going to start with our left firewall. And we know our public IP address is going to be 192.0.2.4/24. Our gateway is the VRRP address, 192.0.2.1. So let's start by configuring up our interfaces. So first of all, let's go into System. Let's go to Settings. Let's set our time and date zones just to simplify things whilst we're doing when we do our synchronization. So we are in London. We will remove the conflict. We will assign our HTTPS port to be 8443 because the SSL port, if we was on the internet and doing for our SSL VPN, it would use 8443. So we don't want to clash with that. So our administration port on our admin interface will use port 80 for HTTP and 8443 for HTTPS. We'll set ourselves as FW3 just to so that we match up with our diagram. We will keep the colors and stuff like that all the same, and we will hit apply. So this is firewall 3. There we go. We can see it in our tab now, firewall 3. So let's go to our network interfaces. So port 1 is going to be our WAN interface. So let's edit port 1. Let's give it an alias, call it WAN. We'll give it its role as WAN. We will say it's a 1 gig uplink, up and down. We'll have a manual IP address of 192.0.2.4/24. As it's an outside interface, we're not going to allow any management apart from ping. And we'll hit on OK. So that's our WAN interface. Our inside interface is going to be port 2, and that's on the subnet of 10.21.20.254/24 is going to be our address. So port 2. We will edit that. This will be our, we'll call it VLAN 20. It's going to be a LAN. And it's going to be a 10.21.20.254/24. We can create this object because it will make it easier for us to refer to it later. Again, we will allow ping to this interface. We won't enable DHCP, and we will hit on OK. So that's our outside interface, inside interface. Let's set our static root. So destination is all the zeros. Our gateway address is 192.0.2.1, which is our ISP's VRRP gateway address, and it's going out of WAN 1, and we will enable it. So there is our default route. So we've got our default route, we've set our time and date, we've set our firewall name, and we've configured our 2 interfaces. Let's jump on to our security policy. Let's create our policy first, and then we will jump onto the HA. So let's configure this as a standalone, and then we'll add the secondary one to the mix. So we're going to create a new policy. We'll call this Internet, and it's going to be coming in on VLAN 20, going out of WAN 1 or out of port 1. The source is going to be this one here. We can edit this and actually call this by its subnet by editing the object. We'll do that later. So call that port 2 address is the source. The destination will be any. And we'll just allow all services for now as we are testing. We're going to say we're going to enable NAT. As you can see here, we enable NAT within the policy, unlike with the Palo Alto, we had to go to a secondary section and add a separate NAT policy. Here, by default, we are adding the policy all in one place. The security, the NAT policy is all done in one section. The same for applying any security profiles. So we're going to enable NAT, and we'll use the outside interface. And we'll click on OK. So that will get us our internet access. So if we now go to one of our desktops that we had previously configured, test 1, 2, 3. What we'll do is we'll double check that we're pointed at the gateway address of .254, because remember in our Palo Alto lab we were pointing at 251 and 252 because we were using active. So here, IP address, yep, 20.254. This one is already in place, so that's good. Let's do a test ping. So ping to 1.1.1.1. And there we go. So this box has got internet access through firewall 3. Firewall 4 is not in play at the moment. Everything is going via firewall 3. So if we look at our dashboard status, view sessions, we can see there we go, our machine on our LAN is able to reach the internet and the traffic flow is being logged on the firewall. If we come back to our policy, we can see, yeah, we've got traffic increasing on this policy. So there we go. So at the moment, we've configured a standalone firewall. If we was to switch this firewall off, desktop 7 can't reach the internet, which is not good. So now let's configure high availability so that in the event that firewall 3 has any issues, firewall 4 can take over. So we're going to go to System, HA. We're going to go to Active Passive. Now, if we look here, the device with the highest priority is likely to become the HA primary. So we will set this one as 200 because it's our left. I like to set our left one as our primary. So it's going to be 200. Our group name will be Null0. And we will set a password. We will enable session pickup so that sessions are synchronized between the two firewalls. This will enable faster failover. We're going to monitor WAN 1 and our inside interface. This is so that if the WAN interface gets disconnected or the interface towards the LAN gets disconnected, we want the failover to happen, not just if the firewall goes off. We also want if our interface goes down in any way that we want the firewall to fall over to our secondary firewall. Our heartbeat interfaces, like I said, are going to be 7 and 6, or 6 and 7. And we'll use them both evenly. So we will just do 50 on each. This is how much we are balancing between the two. So we want to use both of them to balance sessions and heartbeat. So if we look here, highest priority is preferred, but if we set to 50-50, they are equally preferred. So traffic will be equally balanced across the two interfaces. So we will hit on OK. I'm not going to save that to my password vault. I will lock that so it stops interfering. So this will set up our basic active passive for FortiGate. Right, so we can see here's our primary node. Now let's add our secondary so that we actually have some failover. So we have our firewall 4, which is our one on the right. This one here. So we're now going to log into this one, make it synchronize with our device on the left, and it will then go into standby mode. So we'll start with the system area. We're going to set our settings. We're going to set it out as FW4. We will set our time zone to match the other device, London. We will fix up our port conflict there for our SSL, although we're not using it at the moment, but we will do that. I'm not going to do anything else with the config. I'm going to jump straight now into HA, and I'm going to say active passive. The other device, as we remember, we set it as 200, the highest priority, so we're going to set ourselves as 100. The group name was Null0. Password. We enabled session pickup, and we were monitoring our inside and outside interface. And our heartbeat interfaces were 6 and 7. And again, 50, 50, balance it. So we're going to click on OK. Now they are going to synchronize. So as Firewall 4 is now a standby device, its management interface IP address, its outside interface IP address, its inside IP address will all be the same as what is on the active firewall. So they will get replaced. So unless you configure a, if I jump back over to firewall 3, unless you configure a reserved management interface, you will not be able to manage the firewall that is the standby device directly through the GUI unless it is the active firewall. You can go into the CLI and you can connect across to make configuration changes, certain configuration changes, but the only time you will ever really be now editing that secondary firewall is when it is in the active mode. So we've now lost connection to our firewall 4, so we can no longer get to that. If I come back to our FortiGate on firewall 3, the one on the left, you'll see that the secondary role has now been detected and it is now going through its synchronization state. So once this is synchronized, we will see a green synchronized symbol here, and everything will be ready for failover testing. And there we go. We can see our two firewalls, our active and our passive, are now synchronized. So that's software configuration, sessions synchronization, logs, everything is now all in sync. We're now monitoring our outside and inside interfaces for failures to fall over, and we are now monitoring for device failure, and we will fail over. Our left firewall, firewall 3, has the highest priority, so it's got the role of primary on boot up, and the one on our right has the lowest priority, so it will become our secondary on boot up. So if we look at our diagram, we've got our desktop 7. If we look, we are pinging traffic out towards 1.1.1. Let's bring up desktop 8, which is on our other switch on our Nexus VPC cluster. Let's log in here, make sure it's got the same reachability. Open terminal, IP root. And it's pointing at the old 254. So let's point it now at the correct address. I've launched that twice. Desktop 8. Okay, mess that up. Desktop 8. Continue. IP, our gateway will be .254. Let's just put some DNS in just so we can test that as well. Let's double check now. IP root 10.21.20.254. So now this one ping will ping Google. There we go. So we've got desktop 8 pinging to Google. We've got desktop 7 pinging to Cloudflare. So both of our machines are going through the active firewall, this one here, firewall 3, through our internet provider and to the internet upstream. So firewall 3 is currently our primary. So what happens if firewall 3 was to stop? So let's stop it. Let's have a quick check at our machines. We can see there we dropped from 31 to 36. So we dropped to 4 or 5 packets. 69 to 75, for 75 again, 5 or 6 packets. We can see our browser has changed. We hit refresh. We're going to log in. And we should see now, we are now on firewall 4, which is our secondary. Firewall 4 has now taken over as the primary. So we can see that firewall 3 is not here at the moment because it is down, but firewall 4 has now quickly taken over as the backup and is handling sessions and traffic for our 2 clients. We can see both of our machines, desktop 7 and 8, are reaching the internet. So let's bring firewall 3 back online and we should see it take the role of secondary, and firewall 4 will now stay as the primary until there is now a reason for it to fail over. So let's jump on the firewall 4's dashboard here. Let's add the HA widget. If we search HA status, let's add that widget. Let's move it up so we can see it there. So we can see that firewall 4 is the primary, firewall 3 is the secondary, and obviously that is booting up as we speak. We go into system, HA, there we go. We can see firewall 3 is now back online, but it is now in the role of secondary. So all of the active IP addresses are now assigned to this device here. The management IP on port 8, the external IP address on port 1, and the internal IP address on port 2 are now assigned solely to this device. When there is a failover, those IP addresses will become active on this device and this device for management. So it makes it simpler when you're accessing the management interface. You know which one is always going to be up. So that's reachable to the internet. We could see the traffic loss was minimal. Let's test our DNS flow. We do have video playback. Yes, we do. So let's check our sessions, dashboard, sessions. There we go. We can see we've got traffic flow from desktop 7, obviously going to 1.1.1 as a ping. And we've then got 443, which is obviously going to be the YouTube channel playback. So that's all working there on firewall 4. Let's test again. Let's turn off firewall 4. So firewall 3 will then resume the role as primary. If we see here, 217 to 222, we dropped about 2 packets there. We can see our web browser has logged us out. And we can see we're now logging in to firewall 3, and firewall 3 is now the primary. Again, if I look at the status on firewall 3, let's go to its dashboard. Let's add the widget on this one as well. Status HA, add widget. Let's move it up. At the moment, yeah, there we go. We see firewall 3 is now the primary. Let's turn firewall 4 back on. We'll see that firewall 4 will boot back up. It will retain the role of secondary, just like it did before we started our failover testing. And you will see that our devices lower down on the network are continuing to function just as we want them to. Okay, so let's close this. Now let's do a test of destination NAT like we did on the Palo Alto as well. So let's use our simulated public host over here to NAT traffic for a public IP address towards, say, a server, just like we would on a LAN. There we go, firewall 4 is back in line and synchronized as the secondary. So any config changes that we make on firewall 3 will be fully synchronized over to firewall 4, ready to go. It goes without saying, you want to make sure that both your devices have the exact same licensing, the exact same hardware. So you want the same model number, the same if you've licensed IPS, antivirus, web filtering on one of the boxes, you need the exact same on the other as well. If you've licensed a certain number of 40 tokens, again, those will synchronize over once you've added them on one of the devices. NAT, our destination NAT. So we're going to start by going to, where is it again? Policies, virtual IP addresses. We're going to create a new virtual IP. I'm going to call this DNAT1 test. And it's going to be coming in on our WAN interface. It's going to be a static NAT. Our external IP address is going to be 192.0.2.100, just like we did in the others. And we're going to map that to 10.21.20. Let's map it to 8, or server 8. We're going to do all ports, so we're not going to do an individual port. If we was going to do an individual port like for our web server, we could then just say 80 from the outside, map it to 80, just like that. But we're going to map the entire IP address just like we did on our Palo Alto lab. Then we're going to come up to our firewall policy. We're going to create a new, call this our DNAT test. We are coming in on WAN 1, going out to VLAN 20. The source will be for all on the internet, and our destination will be to our DNAT test. This is where I prefer this one because at least like it kind of makes sense over the Palo Alto one. You were kind of putting the public IP address in the policy with the rule, which kind of looked a bit odd. We'll allow all ICMP because we're only going to be testing ping traffic, and we will turn that off. Yes, from what I remember. It's been a while since I've been on a FortiGate. I think we turned that off. So let's just move that up so it's before. So we've got our inbound test rule here. So now let's jump to our public host on the internet, and we will test that we can now ping reachability to our test host. So we want our terminal, and we want to test that we can ping 192.0.2.100. And there we go. We can see that our host on the internet using our destination NAT rule can now reach our host internally. There we go. We can see that we've got traffic increasing here. We can go to our dashboard and we can look at our sessions. There we go. We can see we've got our host on the internet going to our outside public IP address, and it is being natted to our internal network. Again, if we have a quick shifty at the other logs, So there we go. We can see we've got a hit count on our virtual IP. We can see it's being referenced by our rule. So we've got now our inbound test. So now whilst we've got our device pinging inbound from the internet, again, let's now perform a failover test and see what the traffic flow is like. So this is our live firewall at the moment. Everything should be synchronized. Let's stop firewall 3. We're at 77. There we go. 78, 82. So there we go. Pretty damn quick for a changeover. You're not going to skip a beat for an active passive setup using FortiGate. And as you can see, configuration wise, very simple. Well, let's relog back in because as we've seen, we have fallen over to firewall 4. Firewall 4 is still getting the hit counts now. Firewall 4 is the primary. Firewall 3 is booting back up. We can see we've got traffic coming from our source inside. Destinations. Applications that are in use. Any websites that are being accessed. Policies, which of the policies are in use. We can see we've got stuff coming in on our NAT test policy. Because obviously we've got our test machine reaching our internal one. We've got our devices on our LAN going out towards the internet. And we can see the sessions. Under our networking tab is where we configure our interfaces, just like we did on Palo Alto. Again, if we wanted to create a bonded interface, we can create a new interface. We can create an aggregate. We can assign the interfaces to the aggregate interface, just like we did on Palo Alto. We can create VLAN sub VLANs and assign them to our interface. So that's all about interface section. We have our DNS. We can do packet capturing. We've got our static routes, our dynamic routing, our security policy, our firewall policies, and we have our address objects, our service objects, our NATs. So how we do our NATs, either IP to IP or our port NATs. Our security profiles, if we wanted to do antivirus scanning, web filtering, etc. And obviously our standard things like VPN configuration. Admins, firewall, firmware updates, HA configuration, licensing for your FortiGuard, for your firewall firmware updates, intrusion protection packs, updates for your Forti clients, etc. And feature visibility, where you can turn on and off features that you may or may not be using in the firewall. So if you wanted to speed up and streamline the firewall's operation, if you weren't using DNS filtering, endpoint control, you can turn these things off and not have to have the firewall assign resources for them. Certificate management. Now the new FortiGates have the option to renew certificates and set up certificates via Let's Encrypt, and it will renew them for you. So it's a nice little feature. And if you're integrating with Fortinet's other security devices, you can then integrate it into the security fabric. And then we have our logging and reporting, which will either log locally to an internal hard drive, or you can offload it to, again, central logging like a FortiAnalyzer or another syslogging service of your choice. So that is the basic overview of FortiGate and testing of high availability and source NAT and destination NAT. Pretty self-explanatory, actually. It's quite a nice platform to use. It's nice when firewalls are very simplistic, where it's like, okay, so I can go here, I can add a static route, It's like, okay, I want to do some kind of NAT. It's a virtual IP address. It makes it very simple on how you want to do those things. You can do traffic shaping if you wanted as well. Like we saw under feature visibility, there's one here, load balance. So if you did want to do load balancing, you can turn that on. You can then come back over to, where is it again? I think it is under the policies section. Where are you? Virtual servers. There we go. Let's demo that actually. So see where we are doing a ping to just this one for that public IP address of 2.100. So we're going to virtual servers. We'll create a new server. We'll call this test LB. And it's just going to be IP. Going to be on the WAN. The virtual server address will be 192.168.192.0.2.101. And we'll say it round robins. Our health check, you can create a health check, will be ping. And then the two real servers on the inside will be 10.21.20.7 and 10.21.20.8. So that's our virtual load balancer server rule. If we come over to our firewall policy, let's change this policy so that instead of it going to our destination NAT, we're now using we're allowing outside to the load balancer address, which we said was 192.0.2.101, and that will be balanced between the two servers behind. So now if we just do this, we'll remove this virtual NAT or destination NAT just so that it's not in use. And if we come over to our box on the internet, node 11, we should see that that's failing, not going through. And now if we ping to 101, we'll see that we're pinging, but as it's a load balance service, we'll see that traffic is coming in and it is being balanced between two servers. We're seeing traffic going to 7 and 8 on the inbound. There we go, hit count. So we can see that when we're coming in now, we're going to our 101 address, but that's being sent to either one of these in a round robin fashion. Obviously, you can change the balancing method. So it's got built-in load balancing services as well that you may want to use. So it's a pretty nifty firewall, is FortiGate. I do still highly rate them. I don't like some of their issues that they've had in the past with SSL VPN. It looks like they've now moved away from that in all future releases. It is now pure IPsec VPN because of security issues. And sometimes some of their firmware updates can be a bit less than desirable when it comes to reliability. They'll push out an update and something will break. So it's very well worth having a lab environment like this where you can test Fortinet security updates to make sure that everything that you are using, like things like turning on load balancing, are still functioning as you expect, and that your VPN clients and policies are working correctly. So I hope that's given you a brief overview of FortiGate and covered what you can do with it. And hopefully it allows you to go off and configure some highly available Fortinet firewall systems. Next week, we're going to move away from firewalling. We've done two different firewall brands. We're not going to do Cisco as a firewall brand because it's bloody awful. But we will do... we will have a look at some routing next week, some static routing and some basic OSPF configuration. So that's what we're going to do next week. So I will see you then.